This is the second video of the section, Performing Z-Tests. In the previous video, we learned about confidence intervals. In this video, we'll determine whether the observed sample is statistically significantly different from a population with known standard deviation based on standard normal distribution using Z-tests. Before we start, let's look at some basic concepts. When making decisions, it's important to know whether decision error can be controlled or measured. In other words, we want to prove that the hypothesis formed is unlikely to have occurred by chance, and it's statistically significant. In hypothesis testing, there are two types of hypothesis: null hypothesis and alternative hypothesis, or research hypothesis. The purpose of hypothesis testing is to validate whether the experiment results are significant. However, to validate whether the alternative hypothesis is acceptable, the alternative hypothesis is deemed to be true if the null hypothesis is rejected. What is a Z-test? A Z-test is where the test statistics follow a standard normal distribution with a known standard deviation, or variance. Mostly we perform Z-tests to compare whether the two mean values are significantly different. So let's get started. Ensure that you installed R on your operating system. First, we collect the volume of 20 bottles of soft drink in milliliters. Let's assume that this data comes from a normally distributed population with a mean equal to 300 and standard deviation equal to 10. And then we add the soft drink data. Then we run it. We can then calculate the standard deviation error and z-score of the 20 bottles of soft drink. Here's the formula for that. We get negative 4.047283 when we run it. We can now compute the one-tailed p-value from z-score using p-norm function. Alternatively, we can compute the two-tailed p-value from z-score like this. We can then create a function that can perform a z-test and calculate the p-value of either one-sided or two-sided. Let's write the complete code for this. Then click on Run. Keep clicking on Run till you get the enter symbol on the console. We can now calculate the one-tailed p-value and two-tailed p-value from z-score like this. Here's the output. Besides making our own z-test function, we can also find a z-test function in the BSDA package. We will first install the BSDA package. After installing the package successfully, call the library function. For more information, you can run the command !z-test. Amazing! We performed z-tests on the data successfully. In the next video, we'll perform students' t-tests.